now reduce out to n. Not only that if you go to one's positive direction, then this shows that the point goes to the n times this point, but on the circle. So this means that this disk maps to this disk again, but in the covering in n-fold. So if you choose this point, 1 point, then you can find n different one except origin. And now, instead of gz, just consider fz. Now gn plus some variation. If variation is very small, it's very possible that it goes to something like this. Anymore that the image of circle is anymore a circle, but it's not so far from circle. Yeah, because you can just then it goes to, you can show that one gn minus 1 this. And if this is L, and this is very small, then you can show that this is very small, if you like. So that means that this difference is not so big. And then the point is, we really want to know that whether this becomes 0 or not. And that means that the image, so whether this image by this function contains origin or not. And then that, of course, this variation is not so big. Then the image should always contain 0. So that this gives you another very intuitive proof of the fundamental theorem of algebra. Okay. So there are several ways that now that you can explain, but anyway, it's always used sort of kind of some continuity argument. And that's really based on that the real number is obtained by sort of the composition of the rational numbers. Maybe there are several ways to define that the real numbers. And one possibility is using the Cantor's theory, which is sort of the limit. So that any Cauchy sequence of the rational numbers gives some real numbers. So real number is the limit of the rational sequence of rational numbers. So this is a way of the one possible way to explain that why that's the fundamental theorem of the algebra. We are starting with polynomial of complex function, but complex coefficient, but just instead of the complex one, consider the real. And then so again, that if you want to prove that the fundamental theorem of algebra using the factorization, you can always reduce to the case that this is irreducible polynomial. Reducible means that you cannot factorize to the smaller degree equations. And you already know that if you know the fundamental theorem of algebra, then it implies that the Gx is irreducible. Then its degree of Gx is it's linear or quadratic. No more than that. Why? Why that? First of all, any polynomial of odd degree, it has always real 0. That's okay? If degree of gx is odd, then you can find some real number. Why? Because, yeah, this is very simple. If you draw the graph. And for simplicity, assume that gx is started from the a0 xn, and a0 is positive. Okay. Then, if x is sufficiently large, gx is always positive. So the graph goes to something like that. This is the positive part. But x is sufficiently negative. Then this is become negative, since this is odd. So something like this. So by the mean value theorem, or imagination, it should be always hit to the real axis. Okay, so you can find some A here. Okay. That's of course they use for a long time. They use it. So the proof to existence of the root. So actually, basically that to prove the fundamental theorem, the important thing is gx is the positive and even degree. But now that the problem is, so I think this is the way. Actually, what the Gauss proof is in opposite way. So any that's a real, the polynomial of the real coefficient, you can factorize into linear factor or second degree factor. No more than that. So that means that for the real numbers, any polynomial of degree 4, you can always factorize. It's not irreducible. Why? Why? Why so? Yeah, that's I didn't. I skipped that part. What is the property of the polynomial of real coefficient? So, I already tell you that if you have complex numbers, then it's complex conjugated A minus B. Okay? And now, assume that fzx is real. Okay? And assume that f alpha is 0. Then, if you just take the sort of the complex conjugate here, is also 0. And what is the complex conjugate? So, just I like it. A0 x to n plus A1 is x n minus 1 plus A2 x n minus 2. Then f alpha is just here. A0 alpha to n plus A1 alpha n minus 1 plus A2 of alpha n minus 2. Then if you take the complex conjugate, means just you take any place here. That's very easy to prove because that's and the first important fact is beta equal beta bar if and only if beta is real. Yeah, because of the it doesn't change the real part only. So since A0 and A1 and A is a real number, it becomes this one is okay. Yeah? And now, the important part of this complex conjugation is following. You have two complex numbers, alpha and beta, and this is a complex conjugation. Then it's the same as first you take a complex conjugation, of both complex numbers, and take a product. Why? Please do by yourself. It's very simple. Yeah, just express alpha is a plus bi, so alpha is a plus bi, and beta is a prime plus b prime. Okay. Then alpha bar is a minus bi, beta bar is 2 prime plus b prime. Okay. Then what is alpha theta? A prime minus b prime plus a b prime plus a prime b I. Okay. And then take a complex conjugation. This way. Okay, now you need to calculate this one. This is just simple. A minus bi, a prime minus b prime I. So now a prime minus b prime, this is same. And now here's minus a b prime plus a prime b. Okay, so it's almost the same. Okay, so using this, you can, by induction, n is nothing but n. Yeah? So here, you reduce to n. Okay. So what you get is, this is nothing but f alpha bar, because the coefficient is real. Okay, now assume that f alpha equals 0. Then, of course, conjugate of 0 is 0. Okay? So this should be 0. So that means that alpha bar is 0. Okay, so that means that if, so it's a very important part, is if fx is real coefficient polynomial, and if f alpha equals 0, then it's the same, its complex conjugate is also 0. Okay. So if alpha is real, this say nothing, but if alpha is not real, imaginary numbers, then its complex conjugate is also the root, the solution of the equation. And then what you can prove is now x minus alpha and x minus alpha bar. This is part of the factorization of fz. Okay? Because fx can be divided by x minus alpha, but also x minus alpha bar, because alpha bar is also good. And now, if you calculate this, this is x squared plus alpha bar plus alpha bar. Okay? And then point is, this is real number. This is also real number.